In this video, I want to have a look at tangents and normals to logarithmic functions. Now, we've looked at questions really similar to this, but with exponential functions or just with other functions. So there's no notes for this, we're just going to jump straight into some examples. So our first question asks us to find the equation of the tangent to the curve y equals log to the base e of x minus 2 at the point where x equals 3. So we're going to have to use the point gradient form of a line. So y minus y1 equals m outside of x minus x1. So we already have our x value, so our x1 term. We need to find our y1 and our m, and then we can substitute in here. So we know that our x is 3. That means that our y is going to be, and we're going to sub our 3 into here. So we'd have log to the base e of 3 minus 2, which is just log to the base e of 1, and we know that log to the base anything of 1 is 0. So that means our x1 is 3, our y1 is 0. Now we need to find our m. So to find our m, we're going to differentiate. So differentiating this, we would end up with this function in our denominator, so our x minus 2, and the derivative of this in the top, so the derivative of that is just 1. Now at x equals 3, our derivative would be equal to 1 over 3 minus 2, which is just 1. So substituting all of that in, that becomes our m. Subbing it all in, we'd have y minus 0 equals 1 outside of x minus 3. And we'll just end up, if we simplify that, with y equals x minus 3 as the equation of our tangent. Our second example is a little bit different. So it's asking us to find the coordinates of the point on y equals log to the base e of 5x, where the tangent has gradient 2, and then it's asking us to find the equation of the normal at that point. So ignoring this second bit for a minute, we want to find the coordinates of the point on this function where the gradient is 2. So we're going to differentiate this. So we'd have our derivative is equal to 5x on the bottom and the derivative of that on the top, so 5 over 5x, which just simplifies to 1 over x. And we want this gradient to be equal to 2, so we'll put a 2 here. And then we need to rearrange that. So we'd have 2x is equal to 1, so x is equal to a half. So this is the x coordinate of the point where the gradient is 2, but we want the y coordinate as well. So we'll substitute that half back into our original function, and we'd have log to the base e of 5 over 2. All right, so that's the coordinates of the point. Then it's asked us to find the equation of the normal at this point. So we are going to use this form again. So y minus y1 equals m outside of x minus x1. We've just found our x1 and our y1, so our half and log to the base e of 5 over 2. But we need our m. So if this gradient of the tangent is 2, then the gradient of the normal would be the negative reciprocal, so minus a half. So substituting those three things in, we would have y minus log to the base e of 5 over 2 equals minus a half outside of x minus a half. All right, so expanding that out, we'd have y minus log to the base e of 5 over 2 equals minus a half x plus a quarter. Now I don't like working with fractions, so I'm going to multiply everything by 4 to get rid of that. So we'd have 4y minus 4 log to the base e of 5 over 2 equals minus 2x plus 1. And now bring it all over to one side of the equation, so it's in general form. So we'd have 2x plus 4y minus 4 log to the base e of 5 over 2 minus 1 equals 0. So this is the equation of the normal at the point on this function where the tangent has gradient 2. All right, so that's a few examples of tangents and normals to logarithmic functions.